Hello, my name is Stuart Kincaid. I'm a senior manager at Rambus, working in certifications and security architecture. Today, I'm going to talk to you about building trust through the certification process. Now, before I get started, just to let you know, there will be a chance for questions at the end, so you can go ahead and post them during the presentation. Let me just get started then on the next slide. Okay, so I thought it would be useful to have a definition of certification. So according to One Dictionary online, you can see that it's an action or process providing someone or something with an official document attesting to the status or level of achievement. So what does that mean? Well, we all live with certification today. It's all around us already. And we are kind of trained to look for certain labels, stamps, symbols, indicating that a product has been assessed or tested. This may be the safety of your car for NCAP testing, for example, or the guy who works in your house fixing the gas or electricity. He should be qualified and certified to be able to do the work in a safe and accordance to the standards. We travel on rail, bus, plane, train. All of these things are certified that are fit for purpose. The people who drive or pilot these things also are certified to do their job, and we take that for granted. We assume that people are looking after us and have done the correct kind of training, the correct testing, and they've been assessed as fit to do that job. Even at work, we already follow certified processes, and companies go to great lengths to advertise the fact they are ISO 9001 certified, for example, or that their computer systems follow ISO 27001 and are some level of secure. So why do we not apply these standards to how we interact with the digital world? We are more and more connected every day. And with increasing importance, our data, personal information, everything we have now is connected, the so-called Internet of Things. Our personal data is important and valuable. We should ensure we look after it with equal level of enthusiasm as we do for other parts of our daily lives. What we need is a high security product that can be trusted. A certificate may prove that or provide evidence that a product meets or has achieved compliance with specific standards. A certificate means that someone has tested and assessed the product that we use. We rely on them to do the work well and to keep us safe in cyberspace. Hacking into systems can be dangerous, can be costly, can even be embarrassing. In fact, we do everything online today in a connected world, so our personal data may be subject to attack. But how do we trust a certificate? It's just a piece of paper at the end of the day, isn't it? There are several self-certification schemes, but very few for pure security certification. Security testing is not new. There's only a few widely recognized schemes, in fact. Smart cards have been around for a long time. We have them in our wallet for banking. They're in the SIM card of our phone. They're in your passport nowadays as well. They're in health cards, access control everywhere. So common criteria has been used for a long time to test these kind of things. Systems that are connected in the connected world are also more and more being tested and certified against these things. Common criteria is quite a heavy process, though. There's a lot of documentation. The evaluation time is long. It can take years, in fact, to complete a certification. Below that high level of security, there were very few schemes available to fill the gap. You either had CC, which was very secure and difficult to achieve, and then there was pretty much nothing. FIPS filled part of that gap. It has a scheme run by the NIST in the US. They have a cryptographic module validation program, which has been running for many years. In fact, it's also shared with the Canadian scheme, but it's a North American scheme primarily, although countries around the world or companies in countries around the world do use it. But there were really very few options available. If I remember that CC takes maybe 2 years to perform, let's say, Today's world, new machines, new gadgets, new toys are coming around every year. Samsung and Apple have a new phone every year. We trust it. We use it for connecting to the internet. We use it for banking. We use it for the fingerprint sensor, all of our data, facial recognition. Everything is on that phone, and we trust that it's secure. Gadgets can be things like your kettle, although I'm not really sure how you remotely fill the kettle and make a coffee, but they're connected to the internet for some reason. These are coming around faster than the time it would take to do a common criteria certification. And in fact, it would be far too expensive for the value of the product to go through that process for common criteria. So certification at a high level is maybe not appropriate for all aspects of IoT products or Internet of Things products that we have today. This has led to the emergence of so-called IoT schemes, or relatively recently, maybe the last 2 or 3 years, CESIP and platform security architecture are a couple of examples of that are making some inroads into a lighter, more agile scheme. But I should remember that 2 things. First of all, certification does not guarantee absolute security. They are there to show that a product can be certified and tested against the current standards, and that the product can meet those standards. Security is an ongoing process, and for that reason, it should be continually monitored, updated, and developed. All certification schemes have different levels. Some certification schemes are more stringent than others. Some require more time than others, as I mentioned already with common criteria. However, in all cases, the vendor has to demonstrate that they comply with the certification scheme requirements and their product is robust and secure enough to pass the testing. Within the security testing, the algorithms used for the cryptography are also defined as standards, and compliance with those standards is also tested, this time for correct operation during the evaluation. The overall certification looks at the product development process, not just the product itself. We have to be sure that vendors are developing the product in a controlled and organized and auditable way so that we can have traceability. If something does go wrong with a product, how do we find out where that product is used? How do we find out how that product was implemented, where it's shared information with other products? So lots of good processes, controls, tools, and systems are required. A certification scheme looks at these things to make sure that the company performing the certification of the product is also developing that product in a controlled, organized, and manageable way. During the reviews, the labs that will be used are all accredited to the scheme so that you can be sure that laboratories around the world are performing to similar standards and evaluating in the same way. There are management manuals for the labs to follow to make sure they are doing this. There's training for the evaluators who work in these labs to make sure they're all to a good standard and certified themselves to perform the certification testing. The reviews in the lab can be looking at the code reviews or functional testing, perhaps, where it's required. Penetration testing, depending on the level of security, can be performed, such as side channel analysis or DPA testing, fault injection testing, error management, traps, those kind of things. Documentation is very important. And again, that's part of the certification review process, such as the manuals describing how the product is to be used, or some guidance on best practices on how to use it in a secure way. There is no point in having all of the cryptography in the world and then you store the key in plain text somewhere. Then overall, the product lifecycle, how do we update the product? How do we manage the product? All of these parts go towards testing the security well of a good product. So let's take a look at some of these schemes. I mentioned FIPS. So this is a NIST standard, which is based in the US, which is has been running for a very long time. In fact, it took 20 years between the last revision and the current version, despite many efforts to get it updated before that, and it led to many clarifications, guidance, adaptations, and so on over the years. But from September last year, we had FIPS 140-3. This is actually based upon an ISO standard, which is good because that's an international standard, not just North America. ISO 19790 was built to allow customization. And the reason for that is that different countries or regions have different ideas about which cryptographic algorithms can be used in their area. For example, in the US, AES, the advanced encryption standard, is used for symmetric cryptography. Whereas in Korea, ARIA is the standard that is used instead. So again, working within the same framework of the ISO spec, there allows to be customization specifying which algorithms are valid and allowed in a particular region, whilst keeping within the same evaluation and security standard framework. FIPS 140-3 consists of 4 levels, 1 being the lowest and 4 being the highest. Of course, each level brings more stringent requirements as you go through the development process. Also part of the FIPS certification program is a cryptographic algorithm validation program, or CAVP. This is where NIST provides test vectors that must be run through the algorithm you've implemented and the results validated by NIST. Each of these algorithms achieve a certificate as well, demonstrating the correct implementation of that algorithm. These algorithm tests are a prerequisite to the validation of the final cryptographic module that implements them. Once your product has completed testing for the algorithms and then for the module, NIST publishes these certificates on its website. This is a trustworthy repository that can be used to verify that a particular product has an up-to-date certificate and meets the relevant standards. I've listed on the slide here, you can see the website for NIST where you can go and click and find out which products are certified and which the ones you should be using, let's say. Moving on to common criteria, as I said, this has also been around for quite a while now. It's tried and tested method of evaluation of security products. It's famously known for used for smart cards, for example, for the evaluation and testing of smart cards, normally to level EAL4, you can see there and above. There are 7 packages. Each evaluation assurance level comprises of various packages, and you can see that we range there from lifecycle support such as configuration management and bug and issue tracking during development, secure delivery, tools, integration and user guidance as well, how to build the product, how to use the product correctly. The product development process is part of this also, the architecture, the implementation, the testing, and obviously at the bottom you can see vulnerability assessment or penetration testing. This is where the different levels are very, very relevant for the security attack and resistance, depending on the threat model that you see your product being subject to. As I said, the EAL 4 and 5, so level vulnerability assessment 4 and above, is really where the high security products are targeted, such as the smart cards that you rely on for your banking, or the SIM card, or ID in your passport, those kind of things. So it's seen as the highest level of security. And once again, you can see the certified products are listed along with a protection profile describing what was used to certify the product. There is also a security target that goes along with the product. The security target describes the product in good detail and allows you to understand what the claims are and what they should be used for. Moving on now to these other schemes, these were really driven by the fact, as I mentioned earlier, that performing CC certification on IoT products is too heavy. We need to have some lighter schemes. CESIP was developed by people in labs and some industry experts to provide that middle ground between basically nothing and high value CC. And now we have this scheme up and running. It's managed by Global Platform, again, an industry standard recognized around the world. It's a kind of simplified version of CC, less heavy on documentation, certainly at the lower levels. You will see on the slides here that levels 4 and 5 are basically the same as common criteria. Within CC, it's not easy to map to other certification schemes. There are specific industry schemes that exist, such as for industrial IoT or ETSI's consumer standard. CC does not allow reuse in those ways, and basically companies or individual people performing certifications have to go and do the certification again from scratch for each scheme. One of the ideas behind CECIP was that we could map what we've tested here to other schemes. Many of the things are common. Every scheme wants to have a good development environment. Every scheme wants to have controls and processes and demonstrate that. So why would we go through the certification many times? So CECIP allows us to map between one industry specific scheme and another one to speed up the certification process, allows mapping of products across market segments, providing wider opportunities for vendors, increasing sales potential, and obviously reducing certification overhead at the same time. CECIP is certifier is Trust CB, and on their website you can also see a list of the certifications that have been done and the products that are claimed to be certified, along with the level they're certified to. Moving on to PSA, this was developed by ARM Limited in conjunction with security labs and security experts. Again, it was to address this lack of IoT or low overhead, quick to market security certification scheme. It aims to take a simple approach with plain language written to describe what's required, rather than the many acronyms that exist today for many of the security schemes. So those new to the security world of certification are usually overwhelmed by abbreviations, acronyms, buzzwords. So PSA is a more simple approach. PSA have also been clever. They've written a protection profile in the CECIP style, which allows a kind of cross certification between the two schemes as well. Again, looking at how we can minimize the overhead and cost to vendors to ensure that we can reach the markets and our customers that we need to by performing a certification and maximizing the use of that effort. Like all of the other schemes, certified products are listed on the PSA certified website, which I've got the link on the screen for. So looking at the evaluation process at quite a high level here, normally the evaluation process is performed on the final product. And that makes sense as well, because the implementation, the synthesis of the design, the place and route on the silicon chip, all of these things are possible errors. So you want to be able to test the final implementation. But that, of course, brings a risk. There's a time and effort and ultimately cost to design and manufacture the product. And if you get to the end of it and you find you've got a flaw or something is not compliant, it's a huge risk in time, cost. You may miss a market. You may double your manufacturing costs or whatever. But how do we mitigate that risk? Well, one way is complex ICs are comprised of many individual components or IPs. These components may implement critical security features such as root of trust or perform cryptographic acceleration for particular algorithms like AES or public key cryptography and so on. So testing components of the IC can provide confidence that the component satisfies the required standard, performs a particular function correctly before integration. That removes some of the risk, it mitigates some of the risk. IP vendors such as Rambus have been performing testing in advance in such a way to show to customers that we have products that are compliant, that pass the algorithm validation, that can be secure. We provide guidance on how to implement them correctly and securely into the final product. Of course, the final product still needs tested, but it's about reducing the risk, not eliminating it, reducing. Also, because we've taken the time and effort to go through these processes, we're well placed to help our customers, to guide them through the processes as well. We provide documentation and evidence that may be reusable in the evaluation, and that can reduce the overall cost to our customers also. This, of course, may also result in a time to market reduction also. So why should I perform a certification? What do I get for it? Well, more and more markets are actually specifying security as a requirement. If you recall back to the beginning of my presentation, you saw that many customers and products are already safety certified. So why not have a security certification? And this is becoming more true. More people are talking about, does your product have FIP certification? Will it be good enough to pass common criteria certification? These kind of questions have been asked every day to our sales and field applications engineering teams. So security should be treated like safety, a fundamental part of your product. Consumers or customers are actually reassured when a product has a certificate. Trust in the vendor is increased, so there's a benefit for me as a vendor. We've invested time and effort to get certified. We see the benefit of this. The vendor has also got the benefit of having an independent assessment of their product and processes. Makes me feel as if we're doing a good job. So products are evaluated against a recognized standard, developed, reviewed, and maintained by industry experts. So it's not something we're making up on our own. We're getting an external, approved, certified, recognized by the industry group of people to look at our product and assess it against standards. That is a differentiator. So that brings me to the end of my presentation. I want to thank you all today for attending. And I remind you that we take questions. You can post them in during the presentation. Also, you will get a copy of these slides after the presentation. Once again, thank you for your time today.